Hello, pre-calculus. Hopefully yesterday's determinant went pretty well. It is very important to know how to find the determinant because if you notice yesterday I said 7.4a, and that's because the rest of our lesson is coming today, and if you don't know how to find the determinant, it's going to make it really hard to do today's lesson. And so today's lesson we are learning how to find something called the inverse. All right, and we've known inverses for a long time, actually. I have them circled here. 1/3 and 3 are inverses of each other. I know sometimes we say 3 divided by 3. That's the same thing as 1/3. Plus 5 and minus 5 are inverses of each other. Inverses are functions that allow us to undo what was done. And since they allow us to undo what was done, they kind of cancel each other out and we're left just whatever we have right there. So for this one, we would be left just with x. For this one, we would be left just with x. And actually the same thing is going to be true with matrices. If we do the inverse function, we're going to be left with just a very simple number 1. Now the number 1 in matrix math looks a little bit different, so we'll get to that by the end of the period today to make sure we know what that is. But there are 3 steps, and I have 1, 2, and 3 already written right here of what we have to do in order to do that. So I knew I was going to do that. I goofed up on spelling that real quick. I'm sorry. Step number 1, sorry, the F on the find 2. Find determinant. Okay, please find your determinant. That is the first thing you have to do, and that's why we had to do that yesterday to make sure we knew how to do that. Number 2, we're going to do a little kind of flip-flop around, okay? And I know right now when I'm just writing these things, I'm going to underline the whole word flip, but then I'm going to just underline the OP for flop, okay? I know this gets confusing until we actually see it in a minute or two with an actual example, but let's say the original matrix was just like letters instead, so A, B, C, D. They represent numbers, but we don't know what they are. You are honestly going to flip the spot of 2 of them. The other 2 stay in their spot, but they become the opposite. And another reason I like to do determinant first is because I want you to think of your first cross for when you do your cross down. Hopefully you always multiply down first. Would you agree when you multiply down, those are the 2 that you hit? Those are the 2 that we're going to flip spots of. So the D is going to move to the A is going to move to the D. If they were positive, you keep them positive. If they were negative, you keep them negative. Since we flipped those 2 spots, the other 2 we're just going to make the opposite. Now it's confusing on this first one because it looks like that means they have to be negative. But remember, making the opposite actually means whatever is there, you just do the opposite. So if it's already a negative, you make it a positive. If it's a positive, you make it a negative. And so notice D and A switched spots. C and B kept their spots, but they became the opposite symbol of what they were. All right, and if you notice, I said there's 3 steps. We're going to kind of put this all together. It's really weird. We get a determinant in there, and it's in the fraction, and it's in the denominator of the fraction. But you're going to take 1 over the determinant, your thing from step 1, and you're going to multiply it by that flip-flopped matrix. Guys, I know it sounds really kind of confusing, but let's work through a few examples together, and I think you'll see how quick and easy it actually is. If not, if this seems to be really, really confusing and you're totally lost, I am available to talk to you. And so please, your point for today, and I know some of you watch this video later at night because of what time I get your responses and stuff like that. Either Tuesday or Wednesday, please, during actual kind of school hours, unless it's a respectful time after school, I won't talk to you at midnight, okay? But if you would please, and it's a respectable time, would you please try to do a hangout, whether it's just you and me, whether it's 2 or 3 people and me, but I want to check in and see how this chapter is going. So that's how you get your point for today. And it could show up on Wednesday, depending on when you do it. But please, in order to earn your point today, you got to arrange a time. Well, not really arrange a time, just make sure I'm clear and do a Google Hangout with me, please. I would like it to be a video so I can see you and get to see how you're doing. So our first example is this top one. I put 2 per page because I think we don't need that much room. So copy both of them down, but give yourself enough room. So the first thing I'm going to ask us to do is remember what we did yesterday and find the determinant. So you cross down, that's 20. Cross up, that's 18. But since it's 18, we're going to subtract 18. So the determinant this time, our determinant, if we wanted to write it, would equal 2. All right, but the thing is, we don't really need to write determinant equals 2. I'm just worried about the 2, okay? Please make sure that's not a negative 2. 20 minus 18 is 2. So I'm going to remember my determinant is 2. Next, would you please look at the original written here in blue? 5 and 4 are going to switch spots. 6 and 3 stay in their spots, but they become the opposite. What type of 6 do you currently see in blue? What type of 3 do you currently see in blue? Since both the 6 and the 3 were positive, over here they're going to be negative. And so the last thing is, I left myself a little bit of room. I should have told you to do that as well. We're just going to write a fraction in front of that. And so we're going to write 1/2. And in all reality, if we really wanted to, that could be my answer. However, ladies and gentlemen, wouldn't you agree taking half of 4 is still a pretty nice number? So if the number that you get right here can sort of easily be distributed and give you a nice answer, I would suggest distributing it out, scalar multiplication. Half of 4 is 2. Half of -6 is -3. The bottom 2 are odd, so they're not the nicest, but -3 halves and 5 halves. Honestly, guys, I don't really care which one of these 2 you write as your answer. If it's a half and some of the things are divisible by 2, or like if it'd be a third or something like that, and it's something that's nice, please sort of use that scalar multiplication and write this. But honestly, either one of those is correct. So if you would please, let's think about our cross down. Our cross down would be -4 times 6, which is -24. Our cross up would be 2 times 6, which is 12. But that would have to be negative because I was going up and I didn't see any negatives. So you know what? My determinant this time is a big -36. You know, up here we had 2, and I said it wasn't that awful to distribute 2. Down here on this one, it looks like we're going to have 36. That's not so nice to distribute. So I think this time we might just leave that out in front of the fraction. As a fraction, out in front. What 2 values, and be careful this time because I know there's 2 of them, but what 2 values are we going to swap? Correct, the -4 and the 6. Okay, so the -4 and the 6. But then the 6 and the 2 are the ones that stay and get opposite. Stay and get opposite. And again, because these are not the nicest numbers, divisible by 36, I think that right there would be our answer. Pretty easy to find the inverse. All right, I'm going to do one more. At least I have another example if you would like to try, because I want to make sure we understand what's happening when we do that flip-flop because of the way those have kind of all been positive and only one negative. So here's the next page. If you want to copy both of them, you can. If you just want to do the top one, that might be the only one we do. And so if I cross down, I would get -5 times 3 is -15. If I cross up, I get 2 times -7, which is -14, meaning my answer is +14, meaning my determinant this time is -1. -1 is a very nice determinant. It actually, we're going to distribute this one for sure because it's not a big deal at all. All right, would you please look, and that -5 and that -3, we're going to take them and literally pick them up and swap the spots of them. And so the -5 goes down to the bottom, kind of bottom last. First shall become last and last shall become first. That's another way you could think of it because the 5 was kind of the first number we wrote down, excuse me, -5, and now it's the last thing. All right, what type of 7 do you currently see? It's going to stay in that same spot. We're just going to make it positive. What type of 2 do you currently see? So we're going to make it negative. Now, this one gets a little bit interesting too, because 1 divided by 1 is 1. Technically, it's a negative 1. And so I'm going to do scalar multiplication with a negative 1. So negative 3, negative 7, positive 2, positive 5. Those values all switched up because of that. And now some people will say to me, but Ms. Jabs, it looks like you didn't change your negative 7 ever. No, I did. I just had to change it again. All right, so your job is right now to do this one. Hopefully you had written it down or you wrote it down after I did that and you were working on it. 18 plus 8 is 26. Your determinant is 26. Since 26 is a pretty ugly number, I don't think we're going to distribute it this time. And if you do all your flip-flop, that right there should be your answer. So hopefully inverses are going pretty easy. I know we learned determinants for 3x3s, and in all reality, there's a lot of similar things we could do with the way you swap things around and different things like that, and determinant is part of the issue for that one. But we're really only going to have to know how to do the 2x2s. So thank you if you wanted to know how to do this with the 3x3, but it's not going to be needed. All right, guys, why is it so important that we know about the original and the inverse? Remember, if I multiply them together, it kind of cancels each other out, and I'm left with just the plain old number 1. And so I would like to show you what the plain old number 1 looks like in matrix math, because the next few days it's going to be important for us. So this is not one that we've done, but I know it was just given to us, and it's given to you on the homework tonight, that this was our original, and work was already done to find the inverse. These are inverses of each other. And please notice that right here I have asked you to multiply them together. I know it has been a few days since we've multiplied, but please circle the rows of the first and the columns of the second. I suppose I didn't even check if we could do this, but that's because they were 2x2s. So guys, I'm going to do the work as I put the paper down, and I'm going to write this down, but please make sure you're following along, that I would do 6 times 1, which is 6, and 5 times negative 1, which is negative 5. 6 minus 5 is 1. Okay? 6 times, ooh, this is kind of tricky, but make sure you do some math. I'm going to divide first. What's 6 divided by 3? And what's 2 times negative 5? Negative 10. And then we do our 5. So that was just for the fraction. Now we have 5 times 2. 5 times 2 is 10. And so we get 0. Move on to our bottom row. We would get 3 times 1, which is 3. And 3 times negative 1, which is negative 3. Oh, that gives me a 0. 3 times negative 5 thirds, that the 3 cancels out, and I'm left with negative 5. 2 times 3 is 6. Negative 5 plus 6 is 1. Ladies and gentlemen, the matrix that represents 1 is this right here, where we have 1, 0, 0, 1. That is what is called the identity matrix. And the reason it is called the identity matrix, is because when you multiply another matrix by it, it kind of disappears, just like the number 1. Just like the number 1. If we were to multiply any matrix by this matrix right here, we would get the same answer out we originally did. Okay? Guys, I cannot write right now. All right, so that is called the identity matrix. That right there is called the identity matrix. 1, 0, 0, 1. 1, 0, 0, 1. If you want to know what the identity, I know we said we weren't working with the 3x3 today, but Ms. Jabs is going to give us a little bit of a preview. I would write this down if I was you. The identity matrix for a 3x3 would look like that. Please know, whenever you multiply a matrix by its inverse, the original by its inverse, if you do not get the identity, it means you did something wrong. And so that would be a way to check your work if you would want to. I'm not going to make you do that today, but in a couple days when we use the inverse matrix to do something, we are going to need to do that. So a little bit of a shorter lesson today, learning something new. If you need more help, first of all, please remember to get your point for the day. You need to try to get me on video chat sometime. But if you have any more questions, that would be a great time to ask. Maybe you need another example. I'm more than willing to do that. Every single day, I'm more than willing to do another example with you. Thanks, guys. Have a great day.